lab assignment 8, and the topic is belief networks. So starting off with the preliminary questions, first is explain what it means when two variables are independent, also called marginal independence. So it means that two variables are independent if they are not really dependent on each other for their results. So it means that if one occurrence does not affect the likelihood of another one, so it means that either, so for example, a condition A is not affecting the condition B and B is not affecting condition A in any circumstances, and it means that they are independent. So in the notations, it would be like the intersection of A and B. The probability of A's intersection B is equals to the product of the probability of A and probability of B. So it means there is no other circumstances where there need to be any correlation between them. Second up is explain what it means that two variables are conditionally independent. Two variables are conditionally independent in this almost same sense as in the, like they are independent normally or marginal independence. Just in this scenario, we have another variable present across, which means that if we know the value for C, then B, A and B become independent by default. Just we have to know about the information about what the value for C is. So after in this notation, we can see that C, the intersection of A and B in relation to C, and the probability of A in relation to C and probability of B in relation to C, and their product. So if we know the value for C, it becomes pretty much the same formula as this one. So yes, moving on again, question C, what is the independence assumption in belief networks? As we will see in the question of the basic fire alarm, we can see that there are certain nodes and they are connected to each other. So it means that in belief networks, we the specific node is independent of all other node except for its descendants. So it means that all the nodes present below it. So it means that this allows complex joint probabilities to be broken down into simpler conditional probabilities, reducing the amount of information needed to describe the overall network. So it means that all the things that are below any of the node are the things that are dependent on the node. So it means it is not in relation to any of the node before it. So it is, for example, alarm is dependent on leaving is dependent on report, but they have no relation uh, in reverse. So starting up the practical question, belief networks. So going in the value tab, I will try to get the information for smoke. So let's query smoke. We'll get a brief one, and we can see the probability of it being true is 0.0189, and it being false is 9.98 or 98%. So because we have no condition that there is any type of fire or any tempering or so, any kind of fire at all, so it means that there is no smoke, because smoke is dependent on fire being created. So let's toggle monitoring for it. So we can see the result is 0.98. Then in the next part, observe that fire is true. Let's set the condition of fire to be true. Okay, so we can see there is a change. There is a high probability of 0.9 that smoke is present, and it is being observed. So it is 0.9. Observe the fire alarm and alarm, they're both true. So let's make the observation that alarm is true. Okay, so we can see the alarm is true, but there is no really effect on smoke. So starting up in the next part, your answers to E and F same. Yes, they are same, because in the first scenario it was 0.9, and again in this scenario it is also 0.9. Because smoke is not really dependent on alarm in any scenario, it is dependent on fire. So the value, if the value of fire is changed, then the value of smoke is being changed. So if we, for example, set the value of fire to be false, then again the value of smoke changes. But it doesn't matter if the value of alarm is changed. Smoke remains the same because it is independent of the result of alarms. Then we have questions about the independence of fire, various conditions. Let's check it. Yeah. So we have a condition uh, of leaving independent of fire given alarm. So let's get an answer. It is true, and it comes out to true because leaving is independent of fire because it is in relation with alarm. So the value of alarm decides what leaving is going to be. Let's ask another question. Ask it is leaving independent of report. Leaving independent of report given alarm. So let's get an answer. It is false because vice versa, as we have mentioned, this question of the independence assumption in belief networks, we get the result that report is kind of dependent on leaving, like leaving is dependent on the report in a sense. So it means that it is not independent on it and it is in relation to with it. So some kind of value is dependent on report to for leaving. So even it doesn't matter the alarm has been given or not. In the end, the assumption assumes that descendants of it are dependent on it. So that is all for my assignment. Thank you.